Assalamu alaikum. Hi everyone. Welcome for another video series. Belong to NEBOSH Process Safety Management, and this is the third element, like the process safety hazard and controls. So we'll discuss in depth. As usual, I told you every element have some sub elements, like process safety hazard control. Element number 3 of NEBOSH Process Safety Management also have sub elements, like 8 total sub elements. Like 3.1 is all about operating procedures. We're going to discuss how important they are, how they should look like, and how we have to establish them. And then 3.2 is all about safe startup and shutdown, especially in the high hazardous industries. The safe startup and shutdown is very much important, like in oil and gas plants. Safety critical performance standards, which need to be considered. Utilities, electricity or static electricity, how dangerous they are and how we have to manage them. Other chemicals or dangerous substances, we have to understand. 3.7 is all about reaction hazards, and 3.8 is bulk storage operations. So we will discuss 8 sub elements of element 3, process safety hazard control. So let's start with operating procedures. Now, before we move forward, can I ask you all, whoever is watching this video, can you please just look into your personal competence level? Can you develop a procedure? Can you develop a safety policy? Can you write that procedure? Can you write that policy? Can you develop some certain formats or forms relevant to this particular procedure? Like if you have a procedure for plant shutdown or plant startup, or if you are, I'm telling you, please establish or develop these procedures. Can you do them? Can you do it? If not, this is another area you can start learning, and this is how we develop and improve continuously, right? So let's start with operating procedures 3.1. So remember the word SOE, safe operating envelope. This is all starts with the design. Needs to be such as to prevent the hazards being out of control. So in advance, during the design phase, you need to think about what can go wrong and how are you going to prevent them, rather than, sometime I also mentioned the design mistake is the terrible mistake. If a building is designed poorly, what safety we are talking about? If a oil rig site, the design, the site layout is designed poorly, or what safety we are talking about? If a chemical storage area is designed poorly, what safety we are talking about? If the fire safety prevention or fighting system is designed poorly, what safety we are talking about? So that's why the design, during the design phase, you need to inbuild and proactively you need to think all the hazards and inbuilt all the safety features wherever is possible. Now, design itself is controlled within certain limits to prevent hazardous conditions. Like it defines the boundaries of a control reaction, the optimized conditions which keeps the process under control. Operating outside this envelope is unsafe. Pressure relief valve and pressure safety valve are two important segments of this SOE during the design phase. Typical parameters could be like pressure, temperature, and flow rate. So remember PTF. Remember PTF, pressure, temperature, and flow rate. And on the other side, a pressure relief valve, PRV, and pressure safety valve, PSV. So anytime if you're operating outside the envelope, it's unsafe. Now, what is the purpose of standard operating procedures like SOPs? The biggest purpose is it will help and inform to the operator about the process safety hazards. It will also describe the control system and describe standard operating conditions, like including allowable range, exertions. Now let's try to understand, same like other elements, what are some of the key terms like SIS, Safety Instrumentation System. this system actually is a part of different connections and equipment that operates automatically. The process control, for example, valves that maintain the process within SOE, within the safe envelope. Anything goes wrong, automatically the system will be informing us. It will start blinking or giving some red signals and all. Now, different types of SOPs could be there. You know, he can create a question, what type of SOPs are there, like startup, shutdown, plant and equipment maintenance and modification changes. There must be some SOPs. Responding to alarms, tripping and emergencies, filling and emptying charging of vessels, pipelines and reactors, responding to unplanned deviations and abnormal operations. So we need different type of SOPs. Even no harm to prepare SOP for isolation or lockout tagger, or maybe separate SOPs how to isolate, SOP for disconnection and blinding, or SOP for electrical lockout tagout or mechanical energies lockout tagout. So different kind of SOPs technically must be established, and they must be easy to understand for the people, for the concerned technicians or the manpower. And they must follow each step always, every time. And even though if they noted any deviation or they believe this SOP is not fit to the certain process, they must inform to the technical team, and then these SOPs must be reviewed and updated. Because sometimes I noted the SOPs itself are not good enough and missing several technical points. Now, who is involved in developing SOPs? He can create and ask the same question maybe in the exam. Who is involved in developing SOPs? So it's a teamwork, especially the number one, the part of team members are operators, the maintenance team, contractors, and design engineering team. Design engineering team, maintenance, and operators. So OMD. Remember OMD. SOPs development is equal to OMD. That means operators, maintenance team, contractors, design and engineering team. Now, what are the reasons for involving operators in the writing of procedures? Start thinking why we need to involve. Like if you are preparing an SOP for welding process, let's take an example. And do you need to involve welders? Or if you are developing a SOP for abrasive blasting, do you need to get involved with the abrasive blasting operators, or just an example? So think about it. But as per NEBOSH theories, what are the reasons to involve operators in the writing SOPs? Because to ensure the procedure matches what is done, it will help to involve operators, increase acceptance and following of procedures to get sense of ownership. They will start accepting because you engage them, you gave them better respect, and they start realizing, yes, safety is their responsibility and they are the first safety manager of their own area. And their safety starts from themselves. Now, it reduces the likelihood of occurring, but remember, bear in mind, not every element, relevant operator will be able to participate in the drafting, as this is limitation of the effectiveness of individual performance. Don't expect that everyone would be capable to be fully involved with you. Now, what should be included within the SOP? So don't miss any of these parts. First of all, the purpose must be well clear. You know, the purpose of the operation and process, plant equipment materials being used, what are the process steps, who, what, where, how, and why. What would be the hazards and risk, and especially the controls required, and order in which applied. Pictures, photos, drawings, flow charts, checklist must be part of this SOP. Authorization of workers to undertake procedures and PP's requirements. Availability, accessibility of spare parts together with the necessary standard. So these are some of the key elements which must be involved in the SOP. Now, what are the requirements for procedures to be clearly understood? What we have to do is first prepare a draft, have a try, and revise the procedure until it's clear and easily followed. So first you need to develop the draft and then implement as a try. And of course, later on you need to revise if you believe still some clarity required for easily understanding. Now, Now, include operators in the drafting and involve someone not familiar with the procedures to demonstrate it can be followed. Explain not only what and how and also, but also why. Now, you can watch some videos when procedure are fully understood, disasters can happen. Incident at the West Fertilizer Company in Texas. You can search on YouTube, West Fertilizer Company in Texas. You can find this incident and watch this video and see the result. Because in the training, we always show off all these videos, but of course, online, it's not sometimes possible because of a certain distortion or internet issues, But still, you have YouTube, you can search and find out these incidents and see what went wrong and how this incident could have been prevented. Ensuring SOPs remain current and accurate, report and analyze all deviations from the expected process parameters, undertake program reviews and oversight of actual practice, observations or retrospective analysis, quality of end product, careful checking and monitoring of SIS linked to the risk-based inspection, review of MOC like management of change, inspection records and report, the review frequency of maintenance on safety critical plant and equipment. Variations are indicative of potential loss of safety envelope. They can be detected by assessment of defect complaints, product out of specification, reports on deviation in the process, variation yield, adverse, negative, even reports. What are the limitations of SOPs? Yes, there are some limitations. As I told you, everything have some benefits and of course some limitations. So some of the factors that affect operators to follow SOPs. There is a time pressure, workload, staffing levels, training, supervision, human fallibility, and technical issues. In one of the company as a safety auditor, what I noted, they put this tape on the sensor, and I asked the machine operator, why you place tape on the sensor? So he mentioned, the production manager, he needs just production and no time to stop the machine for maintenance. And this is what is guided by the maintenance team to put tape on the sensor, so machine will not stop. So this is what sometimes is happening on ground. Now, consequences of deviating from operating procedures. Now, what could happen, if you deviate from the procedures? Organizational drift could be there, major disaster for both operators, plant, and the organization, reputation. Importance of responding to alarms, example of 3 Mile Island, operators took 2.5 hours to understand the problem. So, responding to alarms is very much important, but sometimes operators took a lot of time to understand the problem. Like Texas is tired and poorly trained operators were there. Essential that operators are trained, confident, and well rehearsed in the required action to take in the event of an alarming activation, and also should reduce unplanned downtime, decrease levels of process safety, improve operator effectiveness, and better process performance. So wherever human capital is involved, make sure they are well informed, well trained, they are knowledgeable, technically sound, the SOP is well understood, they know each step of the process, and they understand the process deviation, they understand the process parameters, and they understand the SOE, the safe envelope, which they need to follow or to play within that. Now let's talk about the safe startup and shutdown, the second 3.2 of element 3, process safety hazard control. Remember, guys, there are different types of startup and shutdown. It can be planned startup or planned shutdown. It can be unplanned startup or shutdown. It can be emergency startup or shutdown, or the stage 1 or the delayed one, startup and shutdown. Let's discuss what is planned, unplanned, emergency, stage, and delayed. Like if it is planned, that means you need to follow predetermined control sequence, includes a risk assessment also. Unplanned is a partial or complete equipment malfunction, could be there, can be dangerous in any event. No, another point is emergency. The types of unplanned shutdown, whenever a hazardous situation develops, stage usually a type of planned startup shutdown that requires stage process like, okay, today this is the stage 1, stage 2, stage 3, 4, in sequence and steps you go for startup or shutdown. Delayed when an issue has been raised, but an assessment is made to control the situation until shutdown is allowed to proceed. So delayed shutdown or startup could also be there. Let's discuss about planned. Startup and shutdown, like turnaround, follow predetermined sequence. Planned shutdown when plant is enclosed for periodical maintenance replacements, planning done well in advance and months even. Risk assessment must be there, linked to product supply and assessment to plant requirements. Unplanned is a shutdown is unexpected, equipment malfunction, power failure, operator error could be there, maybe partial or complete. The absence of a plan makes it more dangerous. The nature of the required shutdown, of course, will have a direct impact on the issues to be addressed, often involves only part of the plan. Emergency, no pre-shutdown review was there when a hazardous situation develops, usually as a result of a breach in the safe operating envelope out of normal scope. Human factor plays a paramount role, but no state difficult to use checklist. High, very high risk. Stay done in stages. Some parts of the large plant may take several days to shut down. Startup progressive plant implementations. All plant shutdowns are generally staged to prevent impacts on operations. But remember, whatever you are doing in high hazardous industries must be written somewhere in terms of SOPs, in terms of procedures or policies or instructions or checklist or some kind of formatting. So make sure you are not doing anything you're not trained for, or if it is not written technically, logically, correct one in terms of procedures. Now, why do you think both startup and shutdowns are potentially dangerous processes? So start thinking and write down some of the reasons, but let's see how NEBOSH is guiding us here. Some reasons startup and shutdown are potentially dangerous because the plant and process controls may be turned off or adjusted for the shutdown, never really know the full status of the process plant and may not be able to plan for every contingency. Plant and process needs to be restored to its steady state, and this will require variation from the normal operating status. Pre-startup safety review is very much important. What factors you need to consider? MOC, like management of change, pressure testing, and gauge control setting, because it's a pre-startup safety review. Safety systems, all operational, mechanical preparation, chemical cleaning instructions, physical cleaning instruction, mechanical restoration, mechanical run as expected, tightness testing. So these are some pre-startup safety review must be done, and these are the important factors to consider. Even pre-startup safety review still required more points to be considered, like electrical testing, functional testing, energizing, operation and calibration of alarms and relief valves, instruments calibration and functional tests, loading of chemicals, loading of catalyst, heaters drying, and even chemicals boil out of steam generation facilities. Alarms, they will assist the operator to identify abnormal, hazardous, and unsafe plant and process conditions. Operators must be able to identify, understand, and respond to alarms appropriately. Consider, do they require an operator response? How they presented to the operator? So these are some of the questions you need to ask yourself as operator. Now, plant shutdown, communication and training is critical. Testing, checking for safety and operational controls like emergency blowdowns, PRVs and trips and alarms, and also checking of plugs and blinds, checking structures and physical connections. Now, let's talk about 3.3 is all about safety critical performance standards. What safety critical performance standards must be there? What is the performance standard for a safety critical system or item of equipment? What are performance standards needed? And what are the sources of performance standards? How we can find out the performance standards? So guys, you truly have to understand the safety critical system or a kind of element A good definition of this term is all about the UK regulations designed for the offshore oil and gas industry. So it's once you join this PSM, Process Safety Management System training, so remember it's a continual, your hobby must be continual learning and researching. Don't stop your learning. Might be this is a good start, but still you need to search. Any confusing word is there, any concept is not clear, start searching, start asking, discuss with me, discuss with YouTube, discuss with Google, even discuss with some of your process safety engineers, and but clear your concept, understand everything in a better shape, so then you will be the best person in a company, inshallah, as a process safety engineer. The failure of which could cause or contribute substantially is to a purpose of which is to prevent or limit the effect of a major accident. What are the performance standards for safety critical systems and necessity to ensure the safety of an asset? Ensure the safety critical elements will perform according to the design criteria and expectations. Each SCE is assessed and interdependency interactions examined. Okay, so as usual with like other terms, we have to understand some of the key terms like what is PS, performance standard, and what is MOC. Even though we have discussed MOC, but still it's better to refresh our terms to understand. Like performance standard, this is the general term used to mean as agreed standard that is set and against which actual performance is measured and judged. Various models and methods are used for testing. Setting performance standards and process safety, like the Farsi model is there. We'll discuss the Farsi model in detail. Management of change and high hazardous knowledge, it is recognized that even seemingly small changes, especially to equipment, can have large potential consequences if they are not thought through properly beforehand. MOC is a management control approach to make sure that proposed changes are properly addressed and authorized. So performance standard, we need to benchmark. Oh, this is the standard we will compare our performance, and this is the MOC procedure which we need to follow even for the smallest changes. Now, what is PHA, process hazard analysis? A systematic analysis of the hazards and their potential causes and consequences relevant to a particular process. This may use one or more specific techniques such as hazard, what if. And what is Farsi is a model for performance standards which can be described in terms of what? Functionality, availability, reliability, survivability, and interdependency, usually abbreviated to Farsi. So remember this term Farsi. Maybe you can create a question. Farsi stands for what? What is the abbreviation of Farsi? So remember, it describes the term what? Functionality. I repeat again, F for functionality, A for availability, R for reliability, and S for survivability, and the last one is I for interdependency. Now, what are the reasons for performance standards? Because we can use, they must be used as the basis for managing the hazard through the life cycle of the plant and installation. It will provide assurance to the critical risk control system will remain suitable and continue to function for their intended purpose. Now, the Farsi model for defining performance standards is all about functionality, availability, reliability, survivability, and interdependence. So let's discuss one by one. What is functionality? It relates to the task the particular element is intended to perform, the standard it needs to perform to, how this performance can be measured, like fire drenching system or reference to the required water flow rate. So we can double check and see either the functionality will go as per the preset standards or. And then availability is part of like proportion of time it needs to be available. and capable to perform? Will it perform under the conditions which are expected? The other key terms to understand is probability of failure on demand, like PFD, probability of failure demand, like PFD, mean time between, like failure, mean time between failure, MTBF, or PDF. This is probability that a component will fail to perform its safe function at the time it is needed. Note that a component may have more than one safety function model of preparation, and PFD may differ for each of these functions. So this is the probability, just remember that one, of failure of demand. Now, mean time between the failure, this is calculated average time that elapses between failures of a system, equipment, or a component. This is used in relation to predicted failures of repairable systems. So we will get different ratings and get the average and see what is the average rate of failure. Now, what is SIL, safety integrity level? This is related to the concept of safety integrity, which is average probability of SES performance function under the stated conditions for a required period of time. The SIL is then used to specify the safety integrity requirements that the SES need to have. There are 4 levels in the SIL system, 1 being the lowest and 4 the highest. Now, safety instrument system, SIS, an instrumented system used to implement either a safety control or a protection function, as SIS is made of 3 connected parts like sensors, logical solvers, final elements. The logic solver decides what actions to take depending on the sensor input. The final element also would carry out the physical actions like the valve. The 3 parts of the SIS may be based on the programming, electronics, and software. Now, reliability, the second one after functionality. Let's understand reliability. How likely it is to operate or fail to operate on demand. Often expressed using probability of failure on demand, like PFD or mean time between failure. Active system can assign what target values, e.g. no more than 1% downtime for individual detectors in any 12-month period. Safety integrity level, SIL, valve used to specify safety need for safety instrumented systems. So these are the all system must be designed and must be part of the plan. Survivability. Survivability, is all about to operate under specified conditions, particularly post-event. For example, fire and gas detection shall survive fire or explosion for as long as the temporary refuge is protected for. So survivability factor must also be there. Interdependencies is all about to other system requires to be functional for it to operate. Do other system require to be functional for it to operate? So interdependencies like fire smoke detection system have a dependency on emergency power and interaction with HVAC or HVAC dampers. So a question for you, what are the interactions, dependencies in each of the following cases like blowdown, deluge, and emergency shutdown? Find out the answers, search. Otherwise, you can WhatsApp me 00966 59 890 3439. You can search in YouTube or Google, and I really want you to develop a hobby like researching hobby and the learning passion, because without passion, of course, you will never be enjoying your job for sure. So let's talk about 3.4 is all about utilities related to process safety hazard control, element 3 of process safety management, NEBOSH Process Safety Management book. Now, utilities, outline 5 main uses of stream in your organization. Uses of stream within the process industry, a source of heating, direct or indirect for spaces and processes. We need steam for heating. We need saturated steam. We need steam humidification. We need motive power. We need, move liquid and gas, separation of vapor steam, like volatile organic is removed, cleaning as well. We need wetting process requiring humidification or moisturizing of materials like paper mills and production. We need atomizing injection steam into fluid atomization and sterilization process we require, especially in pharmaceutical and food industries. We need the properties of saturated stream is all about the boiling point of water, which depends on the pressure. Visible, each vapor coming from a boiling kettle release its heat immediately, more efficient than hot water. Property of saturated stream, we have condensate from formation like steam will wet 3.5% of water may be entertained in the steam, reduce the heat efficiency problem for pipe work. Even reactor vessel condensate like liquid heavy condition has to be moved to near to point of use possible as steam straps or sometimes known as wet stream as well. Now, this steaming process, I hope the people who are working as a reliability engineer or as a WPI or as a WPI or as a CSE super, they could have understand, or as a even process engineer, what I'm talking about, this steaming process, and it can be like saturated steam and even superheated steam. So made from saturated steam subjected to further pressure. An invisible gas temperature could be more than 200 degree. Rapidly release heat does not produce condensate on when it meets air or surfaces. So no water, nothing. It will evaporate everything through heat, But in saturated steam, of course, some humidification will be there. Now, steam hazards, thermal expansion, increased dimension of the solid by rise of temperatures of 5 vessels. Use flexible expansion joint, vacuum formation, like cooling creates condensate, lead to vacuum, vacuum breaks it down, pressure sufficient, like you see this can, we use for Pepsi, Coca-Cola and all. You just remove the liquid and press it up. And once the vacuum is, the air from inside is over, or the gas is broken down, see, and the same way, if you have this water bottle, inside, of course, a certain vacuum is there. So if you remove that vacuum, the rigidity of that outer wall will be gone. Water in steam line, water hammer, water in a pipeline striking a fixed object under high pressure, is a bend or tree in the pipeline, striking the bend. Tree is a vibration caused by the pressure shock, and also mild cases, knocking noise and sway cases, pipe fractures could also happen because of stream hazards. Water hammer, two basic mechanism in steam systems, water entertained in steam being rapidly moved through the pipe, or steam rapidly condenses, because of this low temperature condensation and causes cooler condense to create certain hazards. So water hammer control, make sure you have a good design of pipe work. For process control, removal of condensate, maintain steam traps and drainage, improving the quality of the steam, like minimize water, steam velocity on flow as well. Still, some of the better controls can maintain pipe work insulation, control, avoid pressure drops, avoid the risk of explosion, ensure steam pressure are under control. Vacuum formation during draining operations, draining without proper venting can create partial vacuum. So what is proper venting? Just start searching. I'm telling you some of the better hobbies you need to develop as a passionate learner. Vessel collapse, deformation, ensure vacuum breaker walls. Now, hydrostatic testing. This is again one of the hazards we need to consider during this hydro testing processing. Use for final proof testing to identify leaks. Vessel support designed or gas vessels may not be designed to withstand weight of the water. Vessel pressurized with water, check for leaks, water removed and vessel dried, possible vacuum formation, and also possible corrosion contaminants are removed. Ensure SOPs for venting, draining, and wet conditions or removal of hazardous conditions are there. We can use The weight method, alternative 2, hydrostatic testing, vessel pressurizing with water. Measure weight of the water retained and expel when the pressure is released to calculate the degree of which the vessel in itself is expanded. Few more water hazards like cooling towers. We could get like Legionella or the water fog. This bacteria exists in water and also grows between 20 to 55. 37 is ideal. Feeds on nutritional water. The risk of disease and water droplets containing viable bacteria, cooling towers. In one of the paper industry, they were manufacturing paper cups. And what we started facing is the customer complaints, there is a smell in the paper cup. And once we study our operations, we found fungus in the water and certain, we realized there is, of course, some of the bacteria which are creating issues and mixing with the machine fumes, and we were using some reaming oil and certain kind of chemicals were there. And later on, even though we resolved this issue, but some of the issues were with the paper as well, because the paper is also processed like from cutting the trees and then making the pulp and going to the paper mill, and then from paper mill to the paper rolls and cutting, and then forming this paper cups even after printing. Now, cooling towers control is treat water with a biocide and remove nutrition from the water. Controlling temperatures make up water and in ponds and prevent the spread of the escaping water droplets by fitting drift eliminators. Yes, you need to understand inert gases like noble gases and other gases plus other gases, colorless and odorless, generally unreactive except in rare occasions, used to exclude oxygen, very good fire and explosion suppressant, and also make sure you understand inerting and purging. Inert gas is applied to remove oxygen in the air. The air is forced out. Important to ensure that all the air is removed. Overspill of the inert gas is controlled in assessment made of the likelihood of any electrostatic effect that might compromise the area as fluid are removed or gases are discharged. So be more careful. Even though for purging process we use nitrogen as well. Inerting or purging uses to prevent any fire explosion at person from the forming, removing air oxygen in the system. Reaction processes to displace oxygen or create a non-explosive atmosphere. It will help us to create a non-explosive atmosphere. That's why for confined space, hot works, purging, cleaning, steaming, like the water wash or steaming, or even through purging by using nitrogen is important, because we need a non-explosive or non-hazardous area. So during maintenance, to remove flammable material and oxygen flammable mixtures do not arise. Now, inertic purging hazards and risks are also there. We need to understand, create non-breathable atmosphere, displaces oxygen, nitrogen differentially replaces carbon dioxide, which prevents the breathing reflex. Low temperature potential for serious cold burns. The gases could be there, even the compressed, and the temperature would be different for carbon monoxide, and certain kind of nitrogens even need to insulate storage vessels, danger of direct contact with the people on certain temperatures. Blanketing of storage tanks, addition of an inert gas into the headspace of the tank, it removes the risk of flammable or explosive atmosphere as the tank is being filled or emptied, air entering via vents, the small vents, holes, because an oxygen-rich headspace is left above the liquid in the tank. Firefighting agent, yes, inert gases extinguish fire by replacing the oxygen, risk of exposure to atmosphere. Typically, carbon monoxide used in the office areas, and on some plants, even 52 nitrogen, 40% the other gases, and 8% carbon mixture of the industrial and process plant. Now, the pipeline freezing operations. We use nitrogen often as a coolant because of its very low temperature, including injecting liquid in a blanket around a pipe freezes the content, allowing maintenance, alternations, and repair work, cost effective and relatively easy also. We can use this video or we can watch hazards of machinery and burns and pipe freezing. Nitrogen used as a backup instrument, air, valve and process operated pneumatically may in some circumstances also be operated by nitrogen, dry and readily available. Will not support fire explosion and ensure safety of workers and this pipe work is protected. Oxygen level detectors may be required in work areas to alert workers in the event of nitrogen leak, which will reduce oxygen levels as well. Let's discuss about electricity or static electricity. This is like 3.5 of element 3 of process safety hazard control. Look at this diagram, the basic circuitry for the current flow, plus, minus. We have switch, we have battery here, conventional current flow or electric flow. So we have two different flows, light bulb is there. So potential difference is voltage, current and resistance. So remember, voltage multiply current multiply resistance. The potential difference voltage, current and resistance related by Ohm's law equation, V is equal to I multiply R. So quantity like voltage, volt is A, ampere is electric current, resistance is Ohm. We have two types of current, DC and AC, like alternating current or direct current. Direct current flows in one direction with a constant voltage. The difference between each one of the wires used in short distance applications like batteries. Alternating current is all about a current that changes direction periodically in phases, moving in both directions along the wire, along with its voltage polarity. For application require greater power effectively over much longer distances. Now, hazards of electricity depends on the amount of current flow, of course, and also frequency and path electricity taken from the body and duration. But remember, this slide is important because at the 0.5 to 2.2 milliampere threshold for perception, 2 to 10 milliampere painful sensation, 10 to 25 milliampere inability to let go, danger of aspiration, 25 to 30 milliampere is all about loss of consciousness from heart and respiratory failure, 80 to 2000 milliampere ventricular fibrillation, like erratic heart function, burns at point of contact, 2000 milliampere and above, cardiac arrest, burning of internal organs and tissues, leading to death. Now, frequency of the current may cause muscles spasm and also result in muscle freezing, will cause the hand to hold on and the person will unable to let go. Heart and lungs may also be affected and stop altogether. Electric arcs and sparks occurs when two conductors are separated. Sometimes the loose nuts of the breakers are there, or some loose connections are there. Because of this spark, the sudden blast could also be, and this arc flash or kind of sparks, which would be violent and very much extremely violent, I would say, because extreme heat plus bright light would be there and very much dangerous. Electric arcs and sparks, risk to workers in the vicinity, and also the risk of ignition of any volatile, dust, clothing, risk of explosion, especially if flammable atmosphere is there. Possible serious damage to equipment and the power of distribution system. You can watch some videos related to arc flash demonstration, arc flash accident. I also have these videos, but I want you to search on YouTube and find out the best one and see how arc flash is demonstrating and any sort of arc flash accidents. You will find in thousands. How arc and sparks occur in normal operations? High voltage switch rooms and panels, defective or poorly wired cables and connections, operations of relays, incorrect use of tools. These are some of the terrible reasons, I would say. Adopting incorrect procedure resulting in some of in shorting or bypassing of safety controls, worker live working, especially low voltage system may be at greater risk. The automatic circuit breaker may not be designed to act as fast as that on high and very high voltage installation. So these are some of the reasons how these arcs and sparks can occur. The more are there, like failures in switches, accumulation of dust and debris, and even condensation and corrosion, and poorly faulty design installations. Electrostatic charges, this charge build up on the surface of the non-conductive. You remember in the childhood, we even, what do? We just rub it up and we create a static kind of energy, and we just, small hair or small dust particles, they will touch with it because there was a static energy. So maybe because of this rubbing or because of this particular process of friction, it is created. Now, may be created by pressing two materials together. If the materials are often typed like electrons pulled from the surface of one of them into the other, a static charge is then created. That is why, this while we are filling the big oil tanks or, so what do? We use earthing, we use grounding, we use different kind of methods to make sure there is no static charges or static electricity which could cause terrible explosion. Electrostatic charges, conductors give up or attract electrons relatively easy to that extent exposed to heat, pressure or friction. Electrons material them becomes either negatively or positively charged depending on whether it absorbed or given up electrons. In this condition, the material now represent a potential difference to the surroundings. We then create a potential for sparks to occur as the charge is dissipated. Now, in the explosion atmosphere may have sufficient energy to ignite it. So that is why in oil and gas industry, even the static charges, electrostatic charges must be taken seriously. No other methods of creation is this pyroelectric effect, like applying heat to a material at one point causes the electrons to move and one surface become positively charged and the other negatively. The piezoelectric effect, this is the stress applied to the certain crystals create a charge. Inducing a charge, placing charge material near to a conductor or a conductor which allows its electrons to move freely. The charge material induces a charge into the originally uncharged material. Now, you can have some further research on it, static and like how can static charges occur in process setting, and give some examples how it can happen. Types of static spark discharges, look at the picture. See? Brush charging as well. Discharging, type of static, propagating brush discharge. Types of static conical pile discharge. Spark, we have solid, we have metal vessel, we have tramp metal. Types of static streaming current charge develops in flowing liquids and pipe friction. Contact enable electron exchange to take place. Liquid picks up a charge which is then moved through the pipe and the liquid flows. A cumulative charge on the way, or insulating liquid unable to dissipate charge. Now, typical situation generates static electric movement on conveyor belts, transporting materials, pouring solids and liquids into the containers, sieving, grinding operations, agitation and stirring, and even creation of charge in the workers walking in an insulated surface. How are we going to control them, especially through bonding and grounding? So fixed object, that's why we use grounding, we use bonding. But bonding is more like being used whenever we are refilling different tanks or, we have certain kind of chances where static electricity can create in, we use bonding as well, because we don't need We don't want any chance of heat or spark to be created. Otherwise, the explosion chances will be there. So fixed objects like provide a permanent connection from the plant structure as movable objects such as falling beams. Both require a connection, not covered, in dust or debris. Where direct earthing not possible, liquids we required, different kind of glass line pipe or containers use a tantalum plug in the line by dipping an earth lead extended to the bottom of the container. Now, planning of a power outage. Some consequences might a sudden power outage have an installation such as refinery or large chemical plant. So just what consequences would be there? So two approaches to consider: power outage, uninterrupted power supply like UPS for short time outages up to an hour, generator for longer stages, often in tandem with the UPS. Okay, UPS takes up AC, stores in a battery via rectifier, and then possesses back through an inverter, which restore the DC to AC and then back into the distribution system. Three approaches: offline, online, and line interactive. Good way. Now, uninterruptible power supply UPS, you can see some videos. Generators, it's a portable generators can be used before UPS causes to function, match the power requirements, and kept on site or hired. Safety procedures to ensure safety connection disconnection in energized systems. Now, what would be the fixed generators? Can be installed to match the expected total lead or partial required load of the planet. Daytime between start of the outage and startup of the generators. Power surges. Two critical aspects with generators: maintenance and testing to ensure they are fit for purpose when required in an emergency, ensures adequate fuel supplies are available. So guys, now we are going to discuss the subpart 3.6, dangerous substances. Dangerous substances, three basic physical states are there, like gas, liquid, and solid. Physical forms of dangerous substances can be change state, coexist in more than one state, have different forms like dust and lump. For example, water can be a gas like superheated steam, liquid, and solid means ice. Gases, fire or explosion, flammable gases, harm to the human health, asphyxiate, and corrosive. Liquids are much easier to contain or release, e.g. by burning, than it is for gases. Fire and explosion, fire spread through liquid flow, harm to human, plant, and environment. Solids, risk depends on the shape, form, and size. Large, harder to ignite, explode, react. Small side, dust powders, such as easier to ignite, react. Finally, divided metals are highly dangerous, explode aluminum powder to water. Dust mixed with air, present at a large level, large surface area, creating a flammable atmosphere, easy saving operation. Like, let me give you an example, like H2S, hydrogen sulfide is a dangerous, extremely flammable gas, right? So when H2S meet with, certain kind of other gases or so it create pyrophoric iron sulfide. So it will create a layer on the certain pipe, and that I would say, and with some dust accumulation, we say is became like this dust which can be exploding. And in one of the incident, just from the maintenance technician, one key was fell down, and because the pyrophoric iron sulfide was there at the pipe, that layer was there, and because of this combustible dust, and the key fell down and created this ignition source, and it's all over. So dust was may present a large. We really need to remember. Explosive substances, risk of exploding in the right mixture with oxygen, air, if sufficient energy is available. Explosive substances have very low minimum ignition energies. The energy may be created by heat, shock, or electric charge, such as electrostatic friction. Oxidizing substances maybe add oxygen to other substances easily oxidized. Examples, common oxidizing agents like we have certain kind of nitric acid, okay, hypochlorite, halogen, and even hydrogen peroxide. Flash point, we truly need to understand the lowest temperature at which sufficient vapor is given off the flash, i.e. ignite momentarily or not continue to burn when of ignition applied to the when a source of ignition is applied to the heat vapor. Now, flammable liquid category 1, 2, 3 is all about flash point below 23 and initial boiling point 35, flash point below 23 and initial boiling point above 35, and flash point at 23 and initial boiling point is 60, so flash point between 23 to 60 is inclusive. So that's why we need to put some flammable gases different symbols, and also we need to mention the hazard statement, the signal word and hazard category. Like hazard category 1 is dangerous, extremely flammable gas, because gases ignite when the mixture of 13% in the air, flammable range with air of 12% range of the lower flammable limit. So hazard symbol is given, and also transport symbol is given. So warning, flammable gases for category 2. And then we need to mention the gases are the gases, those are the category 1 have a flammable range while mixed in air. And also now the reaction hazards, so 3.7, how the reaction hazards can, how we have to control them actually. And bulk storage and operator, that is the last part. Let's discuss 3.7, reaction hazards. What is chemical reaction? You need to think about, and what affects how quickly a reaction takes place or whether it happens at all. And sometimes we don't get a second chance, because especially in the confined space. Now, the reaction rate and temperature, look at the flow. And if reaction rate and temperature goes like most reactions and explosion, the very, look at the difference actually between these two lines. I hope you will get the point. So very, minute differences there. As pressure increases, the gas molecules can have more clearance. Catalyst, look at the difference. Energy and extent of reaction is there. So catalyst, the reaction is uncontrollable. Okay. Like we have products, we have reactants, we have catalyst reaction, we have uncatalyzed reactions. Activation energy is uncatalyzed reaction, activation energy is catalyst reaction, but still, the extent of reaction up to that level because of this energy and extent of reaction, the combination about this catalyst is quite clear. Now, exothermic and endothermic reactions. Exothermic, very common, like produces heat, combustion reactions. Endothermic is all about less common, takes in heat from the surroundings, e.g. reactions between vinegar and washing soda. Thermal runaway reaction, increase in reaction rate, heat, exothermic and heat expect to. Now, thermal runaway reactions causes how? Incorrect vessel charging, incorrect reactants, incorrect volumes of reactants. Now, wrong specification of raw material, that's also impurities also create causes this runaway reaction, especially the thermal. Poor failed mixing or poor failed temperature control, loss of power, maintenance failure, instrumentation failure, variation in operation, design failure, insufficient operator training, inadvertent addition or exposure to vessel to fire. Thermal runaway reaction consequences, venting and dumping of the product and materials, loss of production and probably the damage to equipment, unintended chemical reactions such as decomposition or other runaway reactions, vessel overpressure, catastrophic rupture like missiles, loss of containment like toxic flammable, and several incidents you can see for thermal reaction runaway, especially the serious incident in Italy, like 10th July 1972. You can search and see the consequences. Thermal runaway reaction protective measures. What we have to do is containment within the reactor, crash, cooling, drowning, and quenching of reactor, emerging venting, dumping of reactant. So it's again within the design phase, you need to think all these things. Now, bulk storage operations, how we have to make sure the process safety has under control and the bulk storage operations. Now, let's take an example of tanks. So we have 8 types of tanks used to store liquid. We have fixed roof tanks, like atmospheric tanks, external floating roof tanks, internal floating roof tanks, or domed external floating roof tanks, or horizontal pressure or variant vapor space tank, or liquefied natural gas LNG tanks. We have fixed, external, internal, domed, horizontal, pressurized, pressure tank, or variable vapor space, or liquefied natural gas tank. These are 8 types of tanks we are using for storing liquids. Now, hazards and risk. Overfilling, number 1, has the effects of vacuum, overloading of foundation. And failure modes for tank, shells, and associated pipe work. That would be another. Now, overfilling leads to fluid overflows and escape to potential ignition sources, firing, exploding risk. Overfilling is a terrible hazard also. Liquid released through the vents intended for vapor. But if these vents are blocked or they are not working well or not designed well, then it would be horrible. Overpressures of the tank, which then ruptures, typical due to operators unaware of the level of the tank or instrumentation failure in the automatic filling process. Now, effects of vacuum created during tank containment draining, or tank will deform or collapse, use of vacuum breaker valves, loss of pressure in the head space above the liquid is compensated when the tank is empty. Now, overloading of foundations, typically a combination of loading exerted when relatively light tank is filled with liquid, and ground instability like soft or liable movement or loss of containment. Overloading of foundations, it would also ensure solid concrete foundation, circular ring beam foundation design, tank design, construction, and foundation suitable for intended contents. Now, use of anchor bolts where expect high winds. Now, failure modes for tank shells and associated pipe metals used for tanks and pipelines may fail. For example, creep, stress, thermal shock, brittle fracture. All these factors must be considered in liquid. Look at how the strain and the time combination in XY creep failure. Like initial elastic strain is there. It's a primary, then secondary, and then territory creep. So it's a failure. Now, if the stress is there, see how the fracture would be there, like brittle, ductile, or fracture. So remember, the stress loading on a material causes strain, deformation of the material. Materials fall into 2 categories, ductile or brittle. So moves under strain is ductile and breaks under strain is brittle. But at the end, it's a fracture. Now, failure modes for tank shells and associated pipe works, stress loading exerted by the contents, temperature changes, variations in loading, stress period also due to stress corrosion failure, which occurs will corrode and hydrogen embrittlement, incursions of hydrogen atoms, and thermal shock. Also, we need to understand rapid and extreme temperature changes, and also the different cost of the material expand and heat by different amounts causes cracking to develop failure. Brittle fractures is quite dangerous, I would say, occur suddenly under excessive stress, no or limited activity known as snatch loading, and low temperatures can increase fracture and materials used for storing and conveying healthy. Fatigue failure, the formation of cracks as a result of repeated application of the loads, and which individually do not cause failure, may appear as thermal fatigue or contact fatigue, surface or fitting fatigue, or substance cracking on substances fatigue, and corrosion fatigue. Fatigue failure would be like kind of a fracture caused by the combination of cyclic stress or tensile stress or plastic strain, Or the storage tank fitting may also be induced by wind load, vibration, pump induced vibration, pedestrians walking on our components. Now, what sort of things would you need to consider in a bulk storage tank for dangerous substances? So you need to start researching and see how you're going to think and what would be your answer. Notes. Siting of tank, distance for people, property, and other. Look at the process area, the firewall. Okay. See the paragraph 213 and 214 on your book. See table 1 and bund division and see how you're going to store. And boundary fence, bund must be there. Then tanker stand. Setting of tanks, ventilation to allow variation in internal and external pressures during filling and emptying, venting to atmosphere, dispersion of volatiles, avoid flammable explosion mixtures, release to toxic vapors. Filling of tanks, system for filling a tank should be foolproof. Speed tank should be able to equalize pressures by means of the design venting arrangements, procedures, and equipment, competent operators. Overfilling, continuous monitoring to prevent overfilling. The volume of vessel and content should be known before filling. Alarm, 2 alarm trip system, the high level alarm. Normal operations level exceeds, not a reference point for filling operations. High level, like maximum design capability of the tank. And LEHH is exceed that the tank will overpressure and overflow. Road tankers, the mobile nature means that has to be temporary flexible hose connections between the road tanker and the storage vessel. Liquid are pumped between the two, either using the side pump or the local one on the vehicle. This brings additional risk for sure. The risk, what should be there? Drivers drive off, leaving the hose still coupled to the tanker, overcome by using breakaway couple, static, earthing like bonding, dipping rods should be earthed. Okay, siphoning, end of the tank filling below the lowest normal operating level of the liquid, splashing filling with generation of static electricity. Floating roof tank also have, this roof floats on the top of the liquid inside the tank. Two types, internal and external. Advantage on head space above the liquid. Formation of vapor is virtually eliminated. Emissions to air control used for the more flammable liquid, which have a high vapor pressure, low flash point. External floating roof tank, EFRT, like key flexible connectors are there, wall from the foam supply devices. And you truly have to understand, guys, different types of tanks. So then accordingly, it will help you to better understand and be safe at the site actually, because different kind of tanks are there. And as per the design, you need to understand them in a better shape. Now, flexible connectors and valve from foam supply devices, limit chain, float check valve, horizontal supply piping, and continue linear separator nozzles must be there. Typical over 5 to 10 years, landing the roof for maintenance. Roof or FRT will be landed rest on the large, like 1.5 to 2 meter high. Hazard. A tank is empty filled and the space filled with vapor air mixture. Venting is Y and weather and out pressure vents as well. Sinking the roof, a heavy rainfall can result in water loading on the roof. Sinking may result in loss of buoyancy in the roof due to an imbalance of the supporting structure. Incorrect design, if weight of the roof is not supported by the liquid on which the floating due to the insufficient buoyancy. So rim steel fire failure could also be there because of wear and tear, because of tank movement, because of wind pressures. Rim fail, maybe rainfall, maybe surface exposed to air, possibility of flammable exposure, or the risk of fire, or the fire protection system installed on the roof. An ignition comes from either a lightened strike or localized induced static charge. Fixed roof tank and pressure vacuum hazards. Look at, it's well explained. A picture is more louder than words. But try to understand the design of the tank. Bunding is a design construction at least 110% of the total volume of the tank, effective to contain any boiler roof on the top and the bottom, the loss, catastrophic failure, allow for excess inspection and maintenance, allow for rainwater. So you need bunding for sure. Maintained age, steel, wear pipe, work and walls break through wall. Now, shut off valves, both inside and outside. The bund is important in a shutdown, shut off close to the tank. Non-return valves and filling lines, isolating valves and ROSOVs should be fully functional and fail to save. Lines for draining tanks and valves, tank off. So the more technically you understand the tanks, the more better safety, process safety engineer you would. Protection from the extremes of weather, hot and cold climate, temperature variation will affect because of insulation, because of trace heat, high wind could also be distortion, maybe limiting by grinding the tank with metal binds. Lightning strike, this can ignite the volatiles and cause catastrophic failure, can create a current which will induce sparking some distance from the striking point, puncture of the tank, skin or formation of local hot spots, ignite flammable vapors, floating roof tanks susceptible to lightning strike. Now, what are the control measures? Lightning conductors at the appropriate attachment points, tank rim, roof when it is in a high position, inerting to keep the level of flammable vapors down, ventilation to reduce the hydrocarbon in the air. You can have a group discussion or start researching some of these points, like storage of hazardous substances in the warehouse, the number of risks. You can see like allied fire and what factors need to be considered when assessing the potential chemical health presented at their storage requirement. Warehouse assessment, how are we going to do? Understanding the hazardous nature of the substances, may be form, liquid, solid, powder, dust, physical properties, flammability, pH, etc. Relevant reactions, chemistry information, reacts with water, have some STS or formerly MSTS, like safety data sheet or material safety data sheet, or for substances created and stored on site, similar set of information required. Transportation and what and by what inventory, sources of ignition, like including electrostatic or creation of flammable explosive atmosphere. Topography, is a presence of drainage, water courses, vulnerability of buildings, temperatures effects. Local topography and proximity of community buildings, housing, schools, hospitals, legal requirements of separation distances of specified material, LPG cylinders, rules for receiving and dispensing, vehicle movement, access for emergency vehicle, firefighting facilities, open water. So all these are warehousing, siting, location, and security. So trespassers, arson control, stock control, authorized people only, windows and other surroundings, openings. Security should not compromise fire safety, physical control, lockable doors, inadvertent, incorrect storage of incompatible materials, consequences of an untoward event. That means release, spillage and fire, inventory management, reduce the total volume of the material that is exposed to any of the time, separating stories so that the possibility of mass release is avoided. Just in time, resupply and direct delivery to the market. These are some of the better points to understand with the warehouse. This will also help how you're going to segregate the goods. You can take time to understand this diagram. Okay, I hope it will help you. Now, warehouse controls of ignition sources, where flammable identify control, smoking, like use of mobile phone, forklift trucks, hot work, maintenance activities. So that was all about element 3, guys, of process safety management on NEBOSH qualification, one of the most important, I would say, and one of the most important qualifications, especially for the safety professionals, to get in-depth knowledge, technically, logically, and to play their role more effectively. So these are some of the questions or some of the important notes. Prepared by myself. was really hard to type all these, but process safety hazard control. What is Farsi? You need to select right option. Corrective measures commonly used to mitigate the consequences of the thermal runaway reactions are chemical warehousing. Consider what? So you can go one by one with all these questions and find out the right answer. So stay tuned for the last video of process safety management. Is all about fire and explosion protection. Thank you very much. And please feel free to share these videos with your colleagues, with your friends. And this Best International Training Zone channel is for you, for our community, to support them, because sometimes it's really hard to pay a lot of fee and to join these courses. But that is why I started producing all these videos and recording them. Of course, just to save some time or not to make too lengthy video, I'm just rushing up in some of the areas. But of course, it's recorded well, and whenever you get time, you can watch again and again and have a better understanding. And these are the direct presentations. And feel free to please subscribe our channel, Best International Training Zone. And you can contact me via WhatsApp number 00966 59 890 3439. So I'm always there to support you. Thank you very much.